Okay, so this is the week 4 cell structure and function, tonicity, and pH lab walkthrough. So individual assignment like always. I feel like I haven't said that for a while. Make sure you read the manual and the lab all before you do it. It just makes life easier. It's like a cookbook recipe. It's best if you read it all first. And then make sure you put everything into your lab document. And let's see, you want to see the faculty materials, you'll see the students, this will be your formatted lab document, and then we'll have the rubric and the playlist, which you probably are watching now. So let me pause this and open that rubric. Okay, so here's the rubric, the pH and tonicity lab, well, tonicity and pH, I just always call it the pH lab because pH is different. And we have observations, which is always nice, 3 exercises, and then you'll have your points for complete sentences, grammar, 3 sentence lab summaries, etc. So let's pause this and then open the lab. So start with your title page. So title, your name, date, course number, title, your name, course number, date, my name optional. It's all this beautiful stuff. So in this one, it would probably be helpful if I actually opened the key. Excuse me. Scaring my min pin. He's like, what the hell? This one's by me. And I'm like, wasn't landing on you. You have no faith. No faith. Okay. So the key is over here. Alright, so this one you're going to have your 2 test tubes. You're going to say what your solute thingamajig is. So like water, your solution. What it looks like. So which one's crisp, which one's limp. Then in here you're going to say if it's hyper or hypotonic, right? Over here, water solution. Why does it do 1, 2 here? Oh, I don't know, like whatever. You think they would just keep it the same, but why do I expect to know? Okay, so then here you're going to say if it's hyper or hypo. You're also going to say if it's turgid or non-turgid, because we're talking about turgor. And then over here you'll talk about where are the appearance of your cells, like it's stuff all scattered around through your cell. Is it all clumped on the edges? What's it look like? Okay. Then we have the next one. So your pH at the beginning, and then the ending, and then how many drops you added, right? So beginning, they should all be the same, and the ending you should see water have the biggest drop, right? And then the other ones, after a few. I swear no one emails me the whole time that I'm updating stuff, but whatever. As soon as I start talking. Then table 4. So we've got, now we're just looking at the ones with the buffers. So first nothing really changes, and then one should change a lot before the other one. Notice that one's inorganic and one's organic. That'll be important. I'm making like facial expressions that you can't see, so I don't know why I'm doing that. Okay, so then in here, you're going to type a 2 for the buffer and inorganic solution and a 3 for the organic and buffer solution, right? So you'll have like, probably around here is where it starts around 7, so it'll be 2, 3, 2, 3, and then they'll start to veer off from each other, but both go up. So then we have the case of the limp vegetable. It's funny. So what does each look like? Which one's limp, which one's crispy? That tells you why you should have said limp crisp in the table. How can the difference be explained? You said one's hyper or hypo. What does that mean? What caused the change of the experience of the thing? So you talk about tonicity and probably water movement, and we call water movement something with an O. Okay, so are you supported or refuted? Refrigerators make them go limp. Why? What's the air like in the fridge? And then in the exercise, you did 2 of them. What's the third type? And how could we experiment with that, right? So just tell me experiment, which one are you testing for? And then what kinds of cell environmental conditions might affect tonicity in cell? Then let's see, down to 2 for turgor. How can the differences in the appearance of the cells be explained? So the center of it, what happened to that vacuole when you have the salt, basically? Like, how much can I tell you? Appearance instead of the water. So what happened to the water? Which direction did it move? Ooh, let's see. In which direction does it move in a hypo, in a hyper? And then we talk about our plasmolysis, and it says blah, blah, blah. Oh yeah, which state? So hyper, hypo, iso. Could always be an option. Discuss how's your hypothesis, and then why might you see this around your house? Ooh, it doesn't have to be total real world, and now it's just around your home or in nature. So then affecting, now here's just your buffering one. This is the buffering. This is the one that can be a little confusing. So what's your initial pH in the first test tube, which is just water? That's basically your control, right? What's the pH of the water after the acid, right? 4. It should be like 7 to 4 more or less. You might have different things. But whatever this one is, so everybody should start however water started, and they're probably going to come to end around whatever pH the water ended. Maybe higher because you are adding a lot more acid. So then what's the initial, I could just check the table. Let's check. Maybe a little higher, about the same. Okay, so then let's go back. So then what's the initial test tube, blah, 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 for all of them. After you added 5 drops, did you see a change in 2 and 3? When did it change? That should be different for the 2 and 3. And then what caused this dramatic shift in pH? So why is adding more pH going to mess up your buffer? Or more acid, you know. Did the exercise support or refute your hypothesis? Why did this pattern occur? So why are you seeing the buffers get affected differently if they're organic or inorganic? Why? And then what's the differences between the solutions? Is one organic and one inorganic? Which one's which? What is the difference observed in the way the 2 solutions reacted to the acid? So how did the inorganic handle it? How did the organic? Why is the buffering capacity of the organic substances so important to living organisms, including pH? So if you want to live in a world, in our world, is the pH of everything we come in contact the exact same? And then the laboratory summary. This is always 3 sentences, and then add a reference if you need to. That sounds about like it. Usually people have the hardest part with the buffering part, just because you can get weird results. That's why you always have to check everybody else's results too. Hopefully a common trend will emerge. If not, you know I love a draft. Even if so, I love a draft. Send me a draft because I have the answer key and I can make sure you're on target. I think that's everything. I hope this helped. Look forward to seeing those drafts.